Alrighty. So today we are reviewing our transformations. That means next class you will have a test. Okay. So first of all, let's go ahead and just remind ourselves what transformations, or when it says something has been transformed, it really just means it's been moved. Okay, the original parent function has been moved somehow. Okay, so that's really all we're talking about. We have these original parent functions. Okay, so in fact, let's go ahead and just go straight to number 1. Zoom in just a little bit. Okay, so looking at number 1, we have our original parent function here. Okay, so this y equals x squared, that's what we call our parent function. Okay, think of it as the original. Nothing's been added to it. Okay, and let's go ahead and actually name this parent function. This guy is x squared. This is what we call a quadratic. Okay, so this guy is a quadratic function. Okay, nothing's been added, simply x squared. So what we've been doing is we want to find the coordinate points of that original parent function, and we can do that by using a t-chart, where we're going to choose values to plug in for x, solve to find y. Those become our coordinate points. Okay, so we've been choosing a couple negative numbers, 0, a couple positive numbers. Okay, this is just going to give us a good idea of what this graph looks like, or what this function looks like on the graph. Okay, so when I plug it in, so first of all, I'm going to take -2 and plug it in for my x, just the parent function. We'll worry about the transformed function in a second. Okay, so I'm going to plug in -2, so that would give me y equals -2 squared. Well, -2 times -2 is going to give me +4. So when I plug in that -2, I get out +4. Okay, let's do the same thing. When I plug in -1 for my x, this parent function right there, I get +1, because -1 times a -1 is +1. I'm going to go ahead and just zoom back out so we can see a little bit more. There we go. Okay, so let's keep going. 0, pretty easy. When I plug in 0 squared, that's just going to give me 0. Okay, and same thing when I plug in +1 squared, I still get +1. When I plug in +2, I still get a +4. Okay, so I simply just plugged in all those values for x, and I found my y's. Those are now my coordinate points for this parent function. Remember, coordinate points are always listed, parentheses, x comma y. Okay, so let's go ahead and graph this guy. So first coordinate point, -2, +4, right there. -1, +1, 0, 0, 1, 1, 2, 4. Alrighty, so there's our quadratic. Okay, alrighty, so there's our original parent function. Now what we have is our transformed function, where we have some things that have been added to it. Inside the parentheses, we have a +2. Okay, so inside, remember, is always, well, that zoomed in a lot, is always left and right. Okay, so looking at this +2 on the inside, that's going to tell me, draw a little arrow there, looking at that +2, left and right, just looking at it, we think plus, and sometimes we want to think, yeah, it's adding, we're going to the right. But this is the opposite, so this is actually meaning we're going left 2 spaces. And then with our -3 on the outside of our parentheses, or outside of whatever, up and down, this one's pretty straight up. This just means we are going down 3. So what that means is we're going to take each one of these parent function points that we found and move them to the left 2 and down 3. Okay, so I'll start with this point right here. Left 2, 1, 2, down 3, 1, 2, 3. Okay, next point, left 2, 1, 2, down 1, 2, 3. 0, 0, the vertex, left 2, 1, 2, down 1, 2, 3. Okay, this guy left 2, down 1, 2, 3. And my last one, left 2, down 1, 2, 3. Okay, and now we can see that this parabola, this quadratic function, has been moved. It has been transformed to the left 2 spaces and down 3 based on that new equation that we were given. Awesome. All right, let's look at number 2. Okay, so the first thing, we want to identify this parent function. Let's go ahead and name what this parent function is, because you will need to know the names on your test. Okay, well, I see my square root symbol here. That is the name of it. This is a square root function. Okay, so the very first thing we're always going to do, find our parent function points, plug things in for y, or excuse me, for x, and solve for y. Plug things in for x and solve for y. Okay, now here's the thing we need to remember with a square root function. I want to plug in values that are actually going to make sense, meaning a perfect square number, a number I can square root. Okay, so the first perfect square number would be 0. Next one would be 1. And the next one would be 4. And I'm just going to choose those 3. Those 3 are fine to let us know what this function looks like on the graph. Okay, so let's go ahead and plug these ones in. So y equals, it was the square root of x, now it's the square root of 0, because I'm plugging in 0 for x. The square root of 0 is 0. Okay, now my next one, y equals the square root of 1. I'm plugging in 1 for x. Well, the square root of 1 is 1. And my last one, y equals the square root of 4. Okay, well, what number multiplies by itself to give me 4? That would be 2. So the square root of 4 is 2. Okay, and these are our parent function coordinate points. Okay, so let's go ahead and put these on our graph. So I have 0, 0, 1, 1, and 4, 2. Okay, notice it's never going into our negatives. It stops right there at 0 because you cannot square root a negative number. Okay, so make sure it just starts right there at 0 and connect those with not really a straight line because it kind of has that little curvature to it. Okay, but that's our parent function. Those are our parent function coordinate points. Okay, so now what we need to do is we need to identify how it's been transformed here. Okay, so on the inside is always left and right. Okay, so minus, in fact, let's make this note on our paper. Whenever I see a minus on the inside, that means I'm going to the right. Inside. Make these notes actually easy to read. Okay, and if I see a plus on the inside, that means I'm going to the left. So that'll help us. Okay, so since it's a minus on the inside, okay, that means we are going to the right 3. So we're going to take each of these coordinate points, move them to the right 3. And then I have a plus on the outside. Okay, so let's make a little note for the outside. Okay, if I see a minus on the outside, that is down. If I see a plus on the outside, it's up. Okay, so in this case, it is a plus on the outside. So we're going up 1 because it's plus 1. Okay, so now we've identified how it's been transformed. This original square root parent function has been transformed. It's been moved. Okay, so let's take each one of these coordinate points, move them to the right 3 and up 1. I'll start with this 0, 0 point. Right 3, 1, 2, 3, up 1. Okay, my next one, right 3, 1, 2, 3, up 1. It's going to kind of overlap there. That's okay. And then my third one, right 3, 1, 2, 3, up 1. Okay, and we can see it's still the same basic shape as my green one. It's just been moved to the right 3, up 1. And we are done. Beautiful. Okay, same thing. Let's look at number 3. So we are given our original parent function here. Okay, I see my absolute value signs, and that is the name of this function. You will need to know the names. Okay, this is an absolute value. Okay, so let's go ahead and remind ourselves what our absolute value parent function points are. These ones, I'm just going to choose the usual -2, -1, 0, 1, and 2. Okay, we'll plug them in and see what we get here. Okay, so remember, the absolute value means the distance from 0. So if I plug in -2 for x, how far is -2 from 0? Well, that's 2 spaces, so I get out a positive 2. Okay, same thing for negative 1. How far is negative 1 from 0? That's 1 space, so positive 1. Okay, the next ones are pretty easy. How many spaces from 0 is 0? Well, that's 0 spaces. Okay, the absolute value of just positive 1 is still positive 1, 1 space from 0. And the absolute value of positive 2 is positive 2, 2 spaces from 0. Okay, so I have my coordinate points, my parent function coordinate points. Let's go ahead and put them on our graph. Okay, negative 2, positive 2, right there. Negative 1, positive 1, 0, 0, 1, 1, 2, 2. Okay, and we see that the absolute value function looks like a V on your graph. So there's our parent function. Now let's see how it wants us to transform or move this parent function. Okay, so on the inside, I see negative, and we already decided that a negative is right. Okay, so on the inside, we're going to take it to the right 4 spaces, or 4 units. On the outside, I have minus, so then down 5 units. So I'm going to move each one of these points to the right 4 and down 5. Okay, so let's go ahead and do that. I'll start all the way over here. Right 4, 1, 2, 3, 4, down 1, 2, 3, 4, 5. Okay, my next one, this guy right here. Right 1, 2, 3, 4, down 1, 2, 3, 4, 5. Okay, my next one, right 4, 1, 2, 3, 4, down 1, 2, 3, 4, 5. Next one, 1, 2, 3, 4, 1, 2, 3, 4, 5. Notice it's making the same shape, right? 1, 2, 3, 4, 1, 2, 3, 4, 5. Same exact shape. It's just been moved to the right 4 and down 5. Awesome. Okay, let's look at number 4. Okay, so I'm given my original parent function right here, x cubed. Okay, and that helps us with the name of this function. This is a cubic function. Okay, let's go ahead and figure out our parent function coordinate points. X, Y, I'm going to choose the same 5 that I've been using. 1 and 2. Beautiful. Okay, let's plug them in. Okay, so this one you can plug into a calculator. Just make sure you be careful of how you plug it in. Make sure we have some negatives. So negative 2 cubed, remember this is like saying negative 2 times negative 2 times negative 2, which is going to give me a negative 8. Okay, if I were to plug in negative 1 cubed, or negative 1 to the power of 3, negative 1 times negative 1 times negative 1, well, that's going to give me negative 1. Okay, and the next ones are pretty simple. 0 cubed is still just 0. 1 times itself 3 times is just positive 1. But then 2, remember, we've talked about this a couple times, 2 cubed is not the same as 2 times 3. This is saying 2 times 2 times 2, which would give me positive 8. And there we go. Okay, so I have my coordinate points. Negative 2, negative 8 is my first one. Negative 1 right there. 0, 0, 1, 1, and then positive 2, positive 8. So remember, this cubic function creates this tall, skinny S-looking type shape. But there is my parent function for this guy. Okay, now let's decide how it's been transformed, this new function here. Okay, on the inside is left and right. Okay, plus means we're going left. So we're going to take this guy left 1 unit. On the outside is up and down. It's plus 4, up 4. To the left 1, up 4. Alrighty, so let's go ahead and do that. I'll start with this guy down here. Now remember, some of these guys might go off the graph, and that's okay. So I'll start down here. Left 1, 1, up 1, 2, 3, 4. Okay, next coordinate point, this guy right here. Left 1, 1, up 1, 2, 3, 4. This guy, left 1, 1, 2, 3, 4. This guy, 1, 1, 2, 3, 4. Okay, and now this point up here, this one would go off the graph, so I'm just going to go ahead and keep those guys. So again, same shape. It's still going to create that tall, skinny S. It's just been moved left 1, up 4. Beautiful. There we go. Okay, on to our next page. Okay, for numbers 5 through 8, we are asked to write the equation of the function given the transformation in words. Okay, so it's explaining how some type of function has been transformed. We need to write the equation for that function. Okay, well, the first thing I'm going to do just to make sure I get it right, my final answer should always have y equals, right? We're writing these equations. So y equals, and y equals. Okay? All right, so let's go ahead and just take it piece by piece and read what it's saying. So looking at number 5, it says a quadratic function. Okay, well, a quadratic function is going to start with x squared. So I know I'm going to have an x and a squared in my function. Okay, that's been shifted down 3 units. All right, so on the outside, no parentheses. Down 3, I'm going to have a negative 3 in there. Okay, but let's keep reading. And to the left, 7 units. Okay, now left means the inside, so that means I'm going to have to take my parentheses now. Okay, because now there's a left and a right movement. I still have my minus 3, my down 3 on the outside. Okay, but now I have left 7. Well, remember, left is plus. Okay, it's kind of opposite there. So on the inside, I now have a plus 7. Okay, and there's my final answer. My equation is parentheses x plus 7 squared minus 3. A quadratic function, there's my x squared, that's been shifted down 3 units right there, to the left 7 units right there. Beautiful. Okay, let's keep going. Number 6. An absolute value function. Okay, so first it usually tells you what type of function it is, which means an absolute value function. That's been shifted up 2 units, okay, on the outside of the absolute value because they act like parentheses. It's going to be a plus 2. Okay, but then it's also been shifted to the right 4 units. So now we need to open up those absolute values a little bit to give us some space. Because now not only do I have the up 2 units, I now have a right 4 units. So right, remember, subtract, right 4. And there we go. There's our equation. We just got to put it with our y equals. So I have the absolute value of x minus 4, because it wanted us to move it to the right 4 units, and then up 2 units, plus 2. And there we go. There's our finished equation. Okay, number 7. A square root function, so the square root of x is what we're starting with. That's been shifted to the left 3 units. Okay, so this one we're going inside our square root symbol because it's telling us to the left first. Okay, so open up our square root symbol. Left and right's always the inside of something. Left is plus. So plus 3 on the outside, or excuse me, on the inside. On the inside, and then up 5 units. Well, up would be plus, and 5 on the outside. And there's our finished equation. We just got to put it with our y equals. So I have x plus 3 on the inside, plus 5 on the outside. Beautiful. Okay, number 8. A cubic function, cubic x cubed, that's been shifted to the left 4 units. So remember, left and right is always inside. So now we need our parentheses with our x cubed. Left plus, so plus 4 units. And then it's also been shifted down 1 unit. So down 1 on the outside. And there we go. There's our finished equation. The parentheses of x plus 4 cubed minus 1. Beautiful. Okay, so 9 and 10 are kind of like the ones we were doing on our first page. It says, describe in words the transformation from the parent function and the transformed function. Then graph the transformed function. Okay, so here's what I'm going to do. I'm going to go back to my front page because I see that this is a quadratic function. All right, so I'm just going to go ahead and grab these coordinate points from my parent function here. Okay, so I'm just going to copy down what we had for my parent function. We don't have to plug them in again. We got -2, +4, -1, 1, 0, 0, 1, 1, and then +2, +4. Okay, these were my parent function points for a quadratic. The first thing it wants, though, is for us to describe how it's been transformed, kind of like going backwards from here. So first of all, it's a quadratic function. So we're going to write that first down here below our graph. A quadratic function. Okay, now we need to look of how it's been transformed. Okay, first let's go on the inside. -3 on the inside, so minus is right. That's been transformed. That's been transformed 3 units to the right. And I have a +1 on the outside. So that means I'm going to write and up 1 unit. Okay, so there is my explanation in words of how my original parent function was transformed. Now it wants us to graph the original parent, the transformed function. Okay, so here are my original parent function points. I'm not going to graph them both. I'm just going to graph my transformed function, just this guy. But I'm going to use these coordinate points to move them. Okay, so my first coordinate point would be at -2, +4. Right there. I'm not going to put the point. I'm just going to go from here to the right 3. 1, 2, 3, and up 1. Boom. Okay, so maybe I'll do a little, and that'll confuse you. Yeah, I'll do it. So I move from here. I'll just do a little point. I move from here to here. Right 3, up 1. Okay, my next coordinate point would be -1, +1. Just a little coordinate point right there. Okay, right 3, 1, 2, 3, up 1. It's now right there. Next one would be 0, 0, right there. Right 3, 1, 2, 3, up 1. It is now right there. Next one would be 1, 1, right there. Right 3, 1, 2, 3, up 1. It's now right there. And my last one, 2, 4, would be right there. Well, now it went to the right 3, 1, 2, 3, up 1, right there. Okay. So we can kind of see where our original parent points were, those little teeny dots I put on there. But here is my transformed function. Awesome. All right, my last one. So first thing, I'm going to go ahead and just copy down those parent function coordinate points from the first page. Okay, well, that was -2, -8, -1, -1, 0, 0, 1, 1, 2, +8 for my cubic parent function. Okay, so now that I have those, let's go ahead and describe how it's been moved. So the first thing, describe what type of function it is. This was a cubic function. Okay, and I'll just add on, that's been transformed because it's been moved. Okay, now let's see how it's been moved. Okay, on the inside is left and right. Plus means left. That's been transformed to the left 2 units because of that +2 on the inside. And a -4 on the outside. So we're going to write and on the outside is up and down, minus is down, and down 4 units. So there's our explanation in words, how it's been transformed. Now let's go ahead and graph the transformed function. Okay, so -2, -8 would be right there. I'll just put a teeny little dot right there. I'm going to move them to the left 2 and down 4. Left 2 and down 4 definitely is going to go off my page, but that's okay. Let's go to our next one. -1, -1 would be right there. Left 2, 1, 2, down 1, 2, 3, 4. It's now right there. 0, 0, started right there. Left 2, 1, 2, 1, 2, 3, 4. It's now right there. 1, 1, right there. Left 2, down 1, 2, 3, 4. Now right there. Okay, 2, +8 is right there, but it went to the left 2, down 1, 2, 3, 4. Okay, so we still see that it's going to create the skinny S shape that we're looking for, but there is our transformed function.